Today we're looking at rational exponents. By the end of this video, you'll be able to rewrite a radical expression into exponential expressions, rewrite expressions containing rational exponents into expressions containing no exponents at all, and simplify radical expressions by using the laws of exponents. If we take this as our first example, anytime you see a square root, it actually means something to the 1/2 power. So if we take this, what I'm going to do is multiply that 1/2 by whatever exponent is already attached to our variables. So x to the third becomes x to the 3/2. And y to the fifth, since it's under the square root, becomes y to the 5/2. And that's fully simplified. That's our exponential form. Since this is to the 4th root, we're going to write everything to the 1/4 power. Now, before we do that, let's separate it out. We've got the 4th root of 16 cubed. We've got the 4th root of a squared. And in the denominator, we have the 4th root of b to the 6th. So let's take each one separately. The 4th root of 16 cubed, well, the 4th root of 16 is 2, and 2 cubed is 8. So this here becomes 8. A squared into the square root, into the 4th root, is a to the 2/4, which becomes a to the 1/2. A to the 1/2. And finally, in the denominator, we're going to get b to the 6/4, which simplifies to b to the 3/2. But it's in the denominator. And the way we deal with that is we make the exponent negative. So instead, actually, it's b to the negative 3/2. So we get 8, a to the 1/2, b to the negative 3/2 as our final answer. That's it in exponential form. And to be honest, it looks a lot simpler than the original expression did. Now, if I want to simplify an exponential expression like this, what I can do is break it up into parts. So what I can do first is take the square root of 81. Because if we rewrite this as a radical, we get the square root of 81 cubed. And we can either put the cube inside the radical, or we can put it outside the radical. Cubed. The square root of 81 is 9. 9 cubed, 729. So 81 to the 3/2 power is 729. Here we can do the same thing. We've got 8 to the 5/3 power. Let me show you a different way to do this. We have a negative exponent. Since we have a negative exponent, this whole thing goes underneath a fraction. 5/3. Oh, but the negative becomes positive, so it's now 8 to the positive 5/3. If it's 8 to the positive 5/3, we could take the cube root of 8 and then raise that to the 5th power. Or we could simplify 5/3. 5/3 as an improper fraction is 1 and 2/3. So now we've got 8 and 1 and 2/3, which really means that I'm going to take 8 to the 1st and I'm going to multiply it by 8 to the 2/3. Well, 8 to the 1st is 8. 8 to the 2/3. Well, the cube root of 8, to get rid of the denominator, is 2, and 2 squared is 4. So really, this is just 8 times 4, which is 32. So my denominator is 32, so my final answer is 1 over 32. You can take it in parts and break up the exponent, or you can, as in the previous slide, turn it into a radical, square it from there, which is probably easier when you have a calculator. This is the easier way to do it without a calculator. Now, if I'm going to simplify these radicals are something we couldn't simplify before because they weren't the same. And so what we're going to do is raise them to the exponents, and then we can combine exponents. So here we've got 9 to the 1/3 power times 3 to the 1/2 power. What I need to do is get these fractions into a common denominator so that I can add them together when I multiply numbers together. The other thing I need to do is get them to the same base. Currently they're not the same base because one's got a 9 in it and one's got a 3 in it. So we need to get them to the same base. 9 is 3 squared. So what I'm going to do is 3 squared to the 1/3 power, which is 3 to the 2/3 power, times 3 to the 1/2 power. Now I've got to get the common denominator. 2/3 becomes, I need to get a common denominator of 6, so I've got to multiply it by 2 over 2. 4/6, 3 to the 4/6 power, times, I need to get 1/2 as a denominator of 6, so it becomes 3/6. And we add them together, so we get 3 to the 7/6 power. And then we could try and simplify that further. However, it's going to get ugly. We get 3 to the 1st times 3 to the 1/6, because 7/6 is 1 1/6. And that simplifies to 3 times the 6th root of 3. So you could write it like this. You could write it like this. Either way works. Depends on what your teacher asks for. Something like this works the same way. We need to get the same base, but it's 1/3 to the 1/2 power times 9 to the 1/3 power. We need the same base. Since we've got 1/3, we can make the 1/2 negative and make it 3 to the negative 1/2. And for the 9, again, 9 is 3 squared, so we can make it 3 to the 2/3. And common denominator again would be 6, so we get 3 to the negative 3/6 times 3 to the 4/6. Again, since we're multiplying these two numbers together, they have the same base. We add the exponents. 4 minus 3 is 1, so we end up with 3 to the 1/6 power, or the 6th root of 3. Again, depends on if your teacher wants it in the exponential form or the radical form.